Welcome back to Learn as you explore for another mBot2 tutorial. In the previous video, we implemented the line follower in Python. We translated our proportional control block program to Python by referencing the API documentation, uploaded the program to the robot, and tested it out on our mBot2. In earlier videos, we focused on translating block code into Python. Today, we're going to directly add color sensing and obstacle avoidance features to our existing Python advanced line follower code without referring to the block program. Once we have the code developed, we will upload and test it on the mBot2 as always. Before we dive in, here's a quick way to support my work. If you're planning to get an mBot2, you can use my Amazon affiliate link in the description. It won't cost you extra, but as an Amazon associate, I earn from qualifying purchases. Or if you just want to say thanks, there's a buy me a coffee link down in the description too. All right, let's jump in. If you haven't watched my video on the block program for color sensing and obstacle avoidance during line follow, I highly recommend checking that one out first to understand the key concepts. You'll find the link to that video in the description. I'll also include links to the Python API documentation in the description. Bookmark them for easy access because we'll be referring to them often. Let's first open mBlock and load the Python project from our advanced line follower project. Go to File, Open, select your Python line follower project, say OK. Now that it's loaded, we will add some comments to mark where we want to insert the new logic. Before we edit anything in this program, let's make sure to save this as a new file. So select File, Save As, and give your project a new name. I'm going to call this Tutorial 13, Python Color, Obstacle Avoidance, and Advanced Line Following, and say OK. Once it's saved, make sure that you're in your new program before you edit the code. First, we want to do color sensing. We want the robot to detect green, and if the robot detects green on the L1 or R1 sensors, we want the robot to do a 180-degree turn. I'm going to move the reaction to the next line here just to make it clearer in the comments. Next is obstacle detection. If the ultrasonic sensor detects an obstacle less than 10 centimeters away, then we want the robot to stop and wait for the obstacle to be removed. If neither of these conditions are true, continue advanced line following. Now that we have the structure of our code, let's go to the mBuild API section of the Python documentation to get the APIs for color sensing as well as obstacle detection. Later, we will go to the mBot2 section of the Python documentation to get the robot commands for a 180-degree turn and to stop and wait. Let's head over to the documentation pages now. We are now at the mBuild API page. First, we want to find the API for color sensing. So let's scroll down to the sensors part of the outline and look for the quad RGB sensor. Let's look at the different APIs that are available. So we have get line status, we have get offset, is line, is background, is color. So this is interesting because we want to detect color, specifically the green color on L1 or R1. So let's see if this API can provide us what we need. The first argument that we can provide to this API is the color, which is great because we want to detect green. The second argument is CH, which doesn't make much sense, but let's look at the documentation to see what we can provide there. CH says that we can provide any of these strings, L1, L2, R1, R2, or lowercase L1, L2, R1, R2, or the integers 1, 2, 3, and 4. For us, this is perfect because we are interested in getting the green status of L1 and R1 sensors. So this would be the API that we use for color sensing. Let's now move on to the API for obstacle detection. Since for obstacle detection, we're going to use the ultrasonic sensor, let's scroll down to the ultrasonic sensor 2 category. And in here, we see the very first API, and we've also used this previously. It is the ultrasonic sensor 2.get API, which gives us the distance between an obstacle and the ultrasonic sensor. This is perfect for our use case here, so we will take this API for detecting obstacles. Let's now head over to the mBot2 Shield page to find the documentation for turning as well as stopping all motors. We're now in the mBot2 Shield documentation page. So let's go over to motion. The first thing we're trying to find is the turn 180 degrees command. Looking at these APIs, forward is not something that we're trying to do right now, neither is backward. Turn left is interesting. Let's look at this. We want to turn 180 degrees, so we want to be able to provide a turn angle. However, this API takes in a speed to turn at as well as t. And if we look at the documentation, t is indicating the duration of the turn, not really the angle of the turn. So this API is not what we are looking for. The same issue is with the turn right API. It does not take in an angle. Straight is not what we're looking for. And finally, turn. So this is interesting because it does take in an angle for the turn. It turns clockwise, but that is fine. We don't really care about the direction of the turn. We just want to turn 180 degrees. We can also specify a speed for the turn, which is an added benefit. This API is the one that we will use for making the robot turn when it detects green. Next, we need to find the API to make the robot stop when it detects an obstacle. That is something that we've done in the past. We've used the emStop API and provided all as the argument to stop both the encoder motors. Once again, we will use the same API to make the robot stop when it detects an obstacle. Now that we've identified all the APIs, let's head on over to mBlock and continue writing our program. Now let's implement the logic. We want to first do color sensing, so we'll use the mBuild.quadRGBSensor.isColor API. The first argument is the color that we want to sense. The second argument is the channel that we want to sense at, which is first L1. And we can leave the third argument alone because that is the index and it defaults to 1. So now that we've added logic for checking if L1 detects green, we also want to check if R1 detects green, and we want to use the OR operator in between them. This is because if either L1 or R1 detects green, we want to react to it. In order to detect green on R1, we can simply copy this API call that we made here and paste it at the end and simply change L1 to R1. So now that we have our condition defined, the reaction we wanted to do was to turn 180 degrees. To turn 180 degrees, we found the API mBot2.turn, and this takes in the angle to make the turn and a speed. We'll leave the speed as is because it has a default of 50 RPM. Next, let's focus on obstacle detection. We want to perform obstacle detection only if green was not sensed by the color sensor. So we will do this using the elif statement in Python. We now want to get the ultrasonic sensor distance value, so we'll use the mBuild.ultrasonic2.get API and check that the distance is less than 10 centimeters. If it is less than 10 centimeters, we want to stop and wait in this case. In order to stop and wait, we'll use the same mBot2.emStop of all API call. So I'm going to copy and paste that over here. Finally, we want to continue advanced line following only when neither of the above conditions are true. That is, if no green was sensed and no obstacle was sensed, only in that case we want to continue advanced line following. To make this possible, we'll move the entire advanced line following into the else part of this conditional block. To indent an entire block of code to the right, select the block of code that you want to indent and then hit tab once. Now the entire advanced line following logic is within the else block. Make sure to save your code, and that's it. You've now added color sensing as well as obstacle avoidance to our previous line follower code. Let's now upload and test this code on the mBot2 robot. To upload, first make sure to power on the robot and connect it to your computer using the USB cable. Make sure you're in the upload mode and click connect. Select the COM port for your robot, click connect again. Now that the robot's connected, let's go ahead and click upload code. Wait for the upload to complete, and it's done. Let's now take the robot and put it on our test track and see how it performs. For the testing setup, we're using the standard make block line follower sheet with the green square on its path. When the robot detects green, it performs a 180-degree turn, and when an obstacle is introduced within 10 centimeters, the robot stops and waits for the obstacle to be removed. Otherwise, it continues to follow the line. Let's start the robot by pressing button B. The robot begins following the line. On detecting the green square, it does the 180-degree turn and continues in the opposite direction. When we introduce an obstacle, it stops. Once the obstacle is removed, it resumes line following. Upon hitting the green square again, it performs another 180-degree turn. We can stop the program by pressing button A. Congrats! You've now enhanced the Python line following program with color sensing and obstacle avoidance. That's two more sensors integrated and tested in real time. I'm proud of you for following along. Great work! Be sure to show off your robot's new tricks to your friends and family, and feel free to keep experimenting with new sensors and creative ideas. If you found value in this video, hit the like button and subscribe to learn as you explore for more mBot2 tutorials. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.